Good evening, students. Mm, this is my fifth video. Today we have to discuss about isothermal isothermal reversible expansion of van der Waals gas small v van der small d capital W van der Waals gas. In this case, what we do? Now we have to find out the work done. We already studied the zeroth law. We also studied the first law of thermodynamics. We also studied the work done. We know the formula of work done. And using that formula, we have to find out the work done carried out in a condition is isothermal. Isothermal means temperature is constant. Temperature is constant. That means dT is equal to 0. No change in temperature. Reversible. We know that reversible means maximum work done is possible. Maximum work done. Reversible means maximum work done. Expansion means the work done by the system. System will do some work so that suppose this is my system. Suppose this is piston. It undergo expansion. Expansion means work done by the system. System will do work and this piston moves upward. And this is the volume of V1 and this is the volume of V2. So volume expand. So the gas will expand. That means work done by the system. Van der Waals gas. Van der Waals gas means real gas. In our day-to-day life, whatever the gas you face, that is all Van der Waals gas. Van der Waals gas means the force of attraction between the gas molecules cannot be neglected, and the volume of the gas molecule also cannot be neglected. So these two things we have to consider in case of van der Waals gas. That means there exists force of attraction between the gas molecules and the gas molecule occupies some volume. So these two things when we consider, then the ideal gas deviates towards the van der Waals gas. In ideal gas, it was considered that the force of attraction between the gas molecules is neglected and the volume of the gas molecule is also neglected in comparison to the volume of the gas. But these are the drawbacks at low temperature and high pressure. At low temperature and high pressure, the force of attraction between the molecules cannot be neglected. That means there exists force of attraction between the gas molecules. And similarly, at low temperature and high pressure, the volume of the gas molecules cannot be neglected. That means there exists the gas molecule occupy some volume. So these two things are taken into consideration in case of van der Waals gas, where that was neglected in case of ideal gas. So first I have to do some expression for W. We have to do some expression how we express for W. W means work. So condition is that isothermal temperature should be remain constant. Process is reversible. Maximum work done is possible. Expansion means volume. That means the gas system do some work. Van der Waals means real gas, where we are day-to-day life, whatever we use, not ideal gas. Van der Waals gas, one real gas. So we know that first we do the expression for W. The work done by the system. The work done by the system. SYSTEM. Work done by the system means W is equal to minus, because when the system do some work, its energy decreases. By any means, if the energy decreases means it will be negative. You remember this diagram, this is system. If work done on the system's energy increases. In that case, W is positive. If work done by the system's energy decreases. In this case, W is negative. By any means, if system's energy decreases means it will become negative. This will happen in case of heat and work, because heat and work are path dependent function. If you supply heat to the system, Q is positive. If system supply heat to the surrounding, then Q is negative. So this diagram you have to remember, otherwise you have to must do mistake while writing down the significance or the sign. In this case, work done by the system, that means system contains some gas, so work done by the gas, W is equal to minus PdV. That means system I write because system contains some gas. You can write also by the gas, no problem. If you write by the system, no problem, because system means where we do some experiment, that is called system. The rest part is called surrounding, and separation between system and surrounding is called boundary. So system you consider or gas you consider, no problem. So for a reversible process, this is the work done by the system. For reversible process, for reversible process, P external is equal to P internal gas pressure. We add some gas pressure is equal to P internal. That means external pressure is equal to internal pressure. Then maximum work done is possible. Maximum work done is possible. When the external pressure is equal to internal pressure, then maximum work done possible. Maximum work done means it is a reversible process. So then van der Waals equation for n mole of gas you already know. In case of plus 2 you already know the van der Waals gas equation. We also in gaseous state I have to teach you, but it is already in plus 2 you know. P plus n square A by V square whole of V minus NB is equal to nRT. This is for n mole of gas, which is a van der Waals equation, n mole of gas. Now we have to find out this P, because we want to find out external pressure. Whatever the external pressure is equal to internal pressure. So whatever the pressure you get, you put this P value here. So this is my equation 1. Now find out the P value from here. Now I can write P plus n square A by V square. Take this V minus NB to the bottom, to the NR to the right hand side, V minus NB, no problem. Now take P one side, this n square by E to the another side. We get P is equal to nRT divided by V minus NB minus n square A by V square. Now this may be external or internal. You write here internal or external, both should be same, no problem. Now put this external value by external pressure, internal pressure in this equation 1. Substituting this P value in equation 1. Then what we get? Now W is equal to, substitute this value, minus, now I put this value nRT divided by V minus NB whole of, now you make this square bracket here like this, V nRT by V minus B minus n square A by V square. Make this bracket, remove this bracket. Only in place we put here, the negative sign is there. Then here is P into dV. P into dV. Now what you do, now you have to remove this square bracket. What we get, now W is equal to minus nRT by V minus NB dV minus plus minus here minus plus is equal to n square A by V square dV. Now you integrate. You remember this is the work done, you can write del. No problem. If you write del, here is the write del. Here you also write del, because change in work we have to find out, because dV small change in volume. Now integrate both sides of the above equation. Integrate del W is equal to minus integration nRT divided by V minus NB dV, volume change from V1 to V2. That means volume V1 is there and it undergo expansion, it moves to V2. This volume changes, V1 to V2, expansion occurs, then d, then integrating this also plus integration V1 to V2 n square A by V square dV. Now take nRT common to this side, here n square A common to this side. Del W integration is equal to W is equal to minus nRT take common to this side, we get nRT, then integration V1 to V2 dV by V minus NB, then plus n square A take to this side, because these are constant, is equal to integration dV by V square V1 to V2. Now take dx by x, integration of dx by x is equal to ln x. Here dv b, so ln v is equal to W is equal to minus nRT dV by V is equal to ln V minus NV whole bracket V1 to V2 plus n square A. Here I can also write like this, V1 to V2 V minus 2 dV. When you go to the up, it will becomes minus. Now you put first upper limit, then lower limit, then W is equal to minus nRT whole bracket ln first upper limit V2 minus NV, then minus lower limit ln V1 minus NV whole bracket n plus n square A. We know that minus 2 plus 1 minus 2 plus 1, when you take integration, that means it will come like this, my V minus 2 plus 1 divided by minus 2 plus 1. When you start integration, it is equal to V1 to V2, V1 to V2. Now your W is equal to minus nRT, ln x minus ln y, ln x by y, then ln V2 minus NB divided by V1 minus NB. You put the bracket better, plus n square A. Here is minus 2 plus 1, minus 1, so this plus becomes minus. Now this is minus 2 plus 1 equal to V to the power minus 1, 1 by V, V to the power minus 1 means 1 by V, V1 to V2. Now my equation becomes minus nRT ln V2 minus NB divided by V1 minus NB. Make the bracket minus n square A. First upper limit 1 by V2 minus 1 by V1. Now this is the W. This is the expression for W. W is equal to minus nRT ln V2 minus NB V minus NB minus N square A 1 by V2 minus 1 by V1. This is the work done for reversible isothermal expansion of van der Waals gas. This is the formula for the work done. This is the formula for work done reversible isothermal reversible expansion of van der Waals gas. Okay, next, because work done means work done by the system, work done on the system. This is the work done by the system. That is why it comes negative. Now we have to discuss about expression for delta U. This is the expression for W. And now we come to the expression for delta U. Now expression for delta U. Delta U means change in internal energy. We already known that delta U in internal energy means total energy content in a system at constant volume and temperature. That means the total energy content by the heat content in a system at constant volume and temperature, or it is the total energy possessed by the system due to rotational, vibrational, translational, electronic, nuclear, kinetic energy, potential energy, etc. All energy we have to mix. Then whatever the total energy content in a system is called as the internal energy. So that energy may be available for conversion into heat or may not be, but total energy is called as internal energy. Now how we express this internal energy? We know that internal energy is a function of volume and temperature. Internal energy is a function of volume and temperature. That means if we want to find out du, we get what? Now dou u by dou v at constant temperature dv plus dou u by dou t at constant volume dt. This is the internal energy, change in internal energy, small change in internal energy. U is a function of volume and temperature. So du, change in internal energy, dou, this plane D and curve D is different. Plane D means complete differential. Curve D means partial differential. Partial means when a system contains more than one variable, then we vary the one variable with others. In that cases we have to take the partial derivative. That means volume and temperature are two variables, but now here we vary with V, but keeping the temperature constant. But temperature is another variable, but we keep this variable constant. Now we vary this U with variable V. That is why it is written in the form of dou. But if it is only one variable and if vary with only one variable, then we write the plane D. But here is the partial. This is called complete. This is called partial. So the complete derivative change in internal energy is equal to dou u means partial. When more than one variable is present, we write the dou, because it is partially derived. So this according to the first law of thermodynamics, according to first law of thermodynamics, we here write the first law because first law deals with the concept of internal energy. That is why we apply first law. First law of thermodynamics, we write here first law because first law deals with the concept of internal energy. So we deal with the first law. So according to the first law of thermodynamics, del Q is equal to du plus pdv. This is according to the first law of thermodynamics. We take the du, তাহলে du is equal to del Q minus pdv. We know that ds is equal to del Q by T. That means TdS is equal to del Q. So instead of del Q, we write TdS. So here it becomes du is equal to TdS minus PdV. Now differentiate this equation with respect to V, Tv. Now differentiate this equation with respect to V, keeping the temperature constant, because we want this should be dou u by dou v. I need this one. So differentiate this equation with respect to V, keeping temperature constant. What we get? Now dou u by dou v at constant temperature. I write here dou because in this case two variables v and t. So we vary with v, keeping the temperature T constant, is equal to T dou S by dou V. Dou S by dou V constant T minus PdV by dV. dV cancel. We get minus P. Now this equation becomes, now you know Maxwell's equation, because entropy I do not want, entropy is related with the second law of thermodynamics, but still now we did not know what is second law of thermodynamics. So we have to replace this entropy, because entropy is related with second law of thermodynamics. So then we have to change this value. How? Now using the Maxwell's equation. You know, applying the Maxwell's equation, applying the Maxwell's equation, you know, in plus 2 Maxwell's equation, there are 12 such relationships are there in Maxwell's equation. Then dou S, according to Maxwell's equation, dou S by dou V constant T is equal to dou P by dou P by dou T at constant V. This is according to the Maxwell's equation. Now substitute this dou S by dou P value with dou P by dou T. Then this equation, we have to replace this value with dou P by dou T. Now the above equation, dou U by dou V at constant temperature is equal to T dou P by dou T at constant V minus P. This is the equation, and this equation, using this equation we have to move forward. Then we have to know the pressure. We know that the van der Waals, this value we have to substitute. The van der Waals equation is P plus n square A by V square whole of V minus NV is equal to nRT. This is according to the van der Waals equation. I want this P. Take this one to the bottom. We get what? P plus n square A by V square whole of is equal to nRT divided by V minus NV. Now take this one to the side. We get P is equal to nRT divided by V minus NV minus n square A by V square. Now this is the P value. Now we need dou P by dou T at constant volume. Dou P by dou T with constant volume. Now differentiate this P with respect to T, keeping volume constant. Differentiate this equation with T, because we need dou P by dou T. Differentiate this equation with T, keeping the volume constant. So my equation becomes dou P by dou T at constant volume is equal to n is constant, r is constant, volume V is constant, keeping the volume V constant, n constant, V constant. Then what we get? Now nr divided by V minus nV. Dou by dou T, here also T is there, minus here n constant, A constant, V constant, all are constant. So we have to differentiate dou by dou T of n square A by v square, but these all are constant. Derivative of a constant is equal to 0, so this value becomes 0 because all are constant. So dou t by dou t, it is cancelled 1. So my dou p by dou t at constant volume is equal to nr divided by v minus nb. So in place of dou p by dou t, I put this value. Now my equation becomes dou u by dou v at constant temperature is equal to T. Instead of dou p by dou t, I put this value. We get what? nR divided by V minus NB. Now this is equal to the P minus P. In place of P, I write this equation. Then it is minus, I put a square bracket, n RT divided by V minus NB minus n square A by V square, put the bracket. Now now this multiply with this one, we get what? Dou U by dou V at constant temperature is equal to nRT divided by V minus NB minus nRT divided by V minus NB. Now I remove this brackets, minus a minus minus plus is equal to n square A by V square. This one cancel. We get what? Dou U by dou V at constant temperature is equal to n square A by V square. Now I have put this value dou U by dou V at constant temperature, dou U by dou V at constant temperature in this equation. This is equal to dou U by dou V constant temperature. Now put this value in the du equation, first equation. We get what? Now du is equal to dou U by dou V constant temperature, dou U by dou V constant temperature. I put this value here is equal to n square by a v square dv. Now this thing I have to keep as such, dou U by dou T constant volume dt. Remember, the process is isothermal, temperature is constant, so dt is equal to 0 because we carried out this expression for isothermal reversible. Isothermal means temperature constant, dt is equal to 0, so this value is equal to 0. This value 0 multiply with something is equal to 0. Now my equation becomes du is equal to n square A by v square dv. Now I want this delta u value. Now this du value. Now integrate both sides of the above equation. Integrating the both side means here u1 to u2 is equal to du. Now integrate v1 to v2. Here we get n square A by v square dv. Now du integration is equal to u. Then you can find out u1 to u2. But in case of w, remember I did not take w1 to w2 because we need only work. There is no change of work. But here is the absolute value of internal energy cannot be determined. We know from its characteristic that absolute value of internal energy cannot be determined, but absolute value of work done is determined. Here you see, here when we put some integration, I do not take w1 to w2 because if you take w1 to w2, there is a change in work. That w1 to w2 change in work, but absolute value can be determined. That is why I do not put here w1 w2, but I put here u1 to u2 because absolute value of internal energy cannot be evaluated. That I already taught to you in the internal energy characteristic. So now this is n is constant, a is constant, take outside, n square constant, take outside. Here is v1 to v2. Now dv by v square, I take v square of minus 2 dv. Now you first upper limit, then lower limit, u2 minus u1, which is equal to del U, change in internal energy, which we can evaluate it, n square A. Here is integration V1 to V2. Here that means V minus 2 plus 1 divided by minus 2 plus 1 whole bracket of V1 to V2 after integrating. Now your delta U, change in internal energy, is equal to n square A, minus 2 plus 1. Minus 2 plus 1 means minus. So this is, I put here minus. Now it becomes 1 by V, minus 2 plus 1, V to the power minus 1. So 1 by V is equal to V1 to V2. Now here becomes delta U is equal to minus n square A whole of upper limit first, 1 by V2 minus 1 by V1. Heck, bar, heck, जा ये काय आसु रे मांडिया खाइला सब खाइला हौ जाओ तो कथा बुझी कुआडे पसिगला हौ स्टार्ट delta is equal to minus n square A 1 by V2 minus 1 by V1. So this is the internal energy. This is the internal energy. If you remove this minus, you just change it. Delta U is equal to n square A whole of 1 by V1 minus 1 by V2. This is the change in internal energy. Change in internal energy in case of isothermal reversible expansion of a van der Waals gas. So time is already in there. So next class we will taught you the expression for Q, heat and enthalpy. All cases 4. Work done, internal energy, enthalpy and heat. So here 2 is over, W is over, delta U is over, internal work done and internal energy. So we have to teach you in the next class with the heat and delta H. Very short, these are very short distance, but today time is over. Okay, thank you, good night.